Yeah, good afternoon all. So myself, I'm Vijay. Like I hold nearly 18 plus years of experience, which includes nearly 8 plus years of experience in big data, Hadoop and Spark environment. So as part of today's demo, I'll be covering the following topics. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yeah, can anyone please confirm? Is my voice clear?
Yes, sir. The
Yeah,
screen is also big.
fine. Okay. So before I start, let me show you first the contents I'm going to discuss. Right, it's a big data, Hadoop, Spark, Linux, and Python, right, which is going to be covered in this Hadoop, PySpark, Python, and Linux. So total big data. All right. So what is big data? Why Hadoop required? Need for Hadoop sources, challenges, advantages of Hadoop. HDFS, Hadoop distributed file system. We doesn't use any database. We have got some drawback with the database. Despite of the drawback, we are going with a kind of file system called Hadoop distributed file system. Its features, name node, its architecture, right? Metadata management, map reduce is an execution model. Yes, parallel execution model, right? And scoop for import and export operation. For importing and exporting, we use a component called scoop. Yarn, yet another resource negotiator. NoSQL database. NoSQL database is going to be discussed. Not only SQL, that is HBase. HBase is one NoSQL database that will be discussed. And Hive, it's a data warehouse kind of environment in Hadoop framework. Hive working with Hive tables, structured and unstructured data, working with XML data, JSON data, URL weblog data, right? Working with UDF, UDAF, UDTFs, right? Partitioning, non-partitioning, dynamic partitioning, bucketing, indexing, right? And coming to PySpark. Spark introduction, PySpark, right? Need for PySpark. Very high speed processing, right? Using PySpark. PySpark session, PySpark Spark context, RTD, parallelizing, repartitioning, broadcast variables, PySpark, RTD computations, RTD actions and transformations, persistence, memory only, memory disk only, disk and SCR only, PySpark core computations, groupings and aggregations, various groupings and various actions and transformations, inbuilt actions and inbuilt transformations. We know to write huge codings here. PySpark SQL data frame. So data frames here, data frame API, PySpark data frames, structure type, row class, column class, select, collect with column. So one by one built in all the APIs, right? Where filter, order by, group by, join, union, flat map for each fill nulls. PySpark SQL functions, aggregate functions, window functions, date and timestamps. PySpark built-in functions. So PySpark when, lit, split, overlay, explode, collect. So these are the various PySpark functions, external sources, Spark and Hive integration, MySQL integration, working with CSV, JSON, right? Transformations and actions on data frames, narrow and wide transformations, handling nulls, window function, yes. Deployment modes, local mode, cluster mode. PySpark applications, stages and tasks, drivers and executors, building Spark applications, deploying Spark to cluster and tuning and performance tuning. PySpark streaming concepts, integration with Kafka, and PySpark machine learning library. So before you go with, right, PySpark. So if it doesn't have knowledge on this Python, so this Python is going to be covered on a regular basis. Python basics, applications, installations of Python, Python operations, different modes of executions, data types, constants, variables, comments, type conversions, escape sequences, strings, operators, Python IDEs, different working with different IDEs, flow controls, looping, strings, collections, Python lists, tuples, sets, dictionaries, functions, functional programming, modular programming, packages, errors and exceptions, file handling, object-oriented programming concepts in brief, regular expressions, database connectivity, Python, datetime, OS model, iterators, generator, closes, working with CSV, XML, JSON, graphic programming, Excel workbook, data analytics, Pandas, NumPy, Matplotlib, introduction to data science, Python, Pandas, NumPy, model in brief, and Python, Matplotlib, right? This is what will be covered. Yes. And everything we are going to run on Linux environment. Linux is going to be covered, right? Basic Linux. Fine. So starting with this set, what is big data? So that is the course content will be covered in brief for both us. What is big data? And just observe this. So you got which includes PySpark, Linux, and Python will be covered. Yes, these four things. So it's 15,000, right? The 15,000 is the fee structure. That is one. If you have got knowledge on Python already, if you doesn't want a Python, Hadoop, PySpark, and Linux, it's 12,000. So with Python or without Python, right? Yes. So if you want this Hadoop, PySpark, and Linux, this Python will be of 2 months. 2 months Python sessions will be discussed on a regular basis. And this Hadoop, PySpark, and Linux, like 12 weekends, it's a weekend batch, right? 12 weekends to be discussed, and this will be weekday batch. You can attend any of the Python batch that is going currently, right? On Monday to Friday, it will be Python sessions. And this Hadoop, PySpark, and Linux will be on weekends, 12 weekends, right? It's nearly like 3 months it takes. Fine. So coming to this, right? What is big data? All right. Currently, data is getting so here. What is big data? Why Hadoop required and drawbacks with the current databases? Why we are? What are the drawbacks with the current databases and Hadoop and Spark advantages? Hadoop and Spark job market. So big data, right? Huge volumes of data. Currently, how the data is getting stored, right? KBs, MBs, GBs, TBs, petabytes, petabytes, exabytes, zettabytes, etabytes, ottabytes. So you should have seen GBs, TBs, or even petabytes, right, of data. 1 petabyte equal to 1024 TBs. 1 petabyte equal to 1024 TB. So currently we have got databases like Oracle, MySQL, DB2, SQL Server databases, right? For OLTP, online transactional processing. And we have got specialized databases like Teradata, Netezza, Vertica, used for data warehouse purpose, analytical processing, online analytical processing. But these databases can handle data up to some extent. But beyond that, so they cannot handle the data. So as a solution to all the storage level problems and processing level, right? So we have got that. See, today if you see huge data is getting generated everywhere, right? If we take petabytes of data means example of petabytes of data generation. If you take example of a Facebook, what is the data generated by Facebook in a minute? What is the data generated by a Facebook in a minute? Means millions and billions of users using Facebook. What so how many posts and videos are getting circulated? What should be the storage capacity, right? but data generated by Facebook in a minute in petabyte. Not only Facebook, if I take 1 minute of transaction, take what is the data generated by Facebook in a minute, data generated by Twitter in a minute, data generated by Google queries, and everyone creating your own videos and uploading in the YouTube, right? YouTube videos upload. What should be the storage capacity to store all the videos? And email messages. What should be the storage capacity to store all the messages, right? And bank transactions. Talk about the bank transactions. If I talk about the telecom transactions, and if I talk about this e-commerce sites like Flipkart, Amazon, all this. So everywhere you see in this, either Facebook or Twitter or Google or YouTube or e-commerce sites, everywhere petabytes of data is getting generated. To handle this huge data, petabytes of data, and to process this petabytes of data, right? So we have got a framework, right? We have got a framework, Hadoop, right? It is meant for both storage and processing. So if you take any technology, they're either store or process. Example, C, C++, Java, all this they are used for processing. Oracle, MySQL, DB2, all this they are used for storage. But Hadoop performs both storage and processing. It stores and process. For storage, it doesn't use any database. Hadoop, for storage, it doesn't use any database because I said there are some drawbacks with the current databases. Despite of these drawbacks, still Hadoop doesn't go with the database. It is going with a kind of file system called Hadoop distributed file system. So Hadoop is meant for storing and processing. For storage, it uses Hadoop distributed file system. And for processing, it uses MapReduce or Spark. It doesn't use any technology like Java or these things. It's going with the execution model called MapReduce or Spark. Yes. So both for Hadoop and for both storing and processing. You may get a query, right? So if Hadoop is able to store and process, what is the necessity of these databases and these technologies like C++, Java, all this? You need to clearly understand Hadoop is meant for batch applications. Hadoop is not for online applications. Hadoop is not for online applications. For one transaction, no need to go for Hadoop. Go with the databases. Batch applications, there are two types of applications. Hadoop is meant for batch as well. Two types of applications, online applications and batch applications. Online applications means user interactive applications. Here user gives the input. Batch applications means user non-interactive applications. User non-interactive applications. Here user is no way required. Here online application means booking a movie ticket, making an online transaction, making an online transaction. User non-interactive applications means user is nowhere required. Means railway ticketing PNR status. Currently the status, your waiting status is 200. After 1 hour it is 150. Today evening it became like 100. Tomorrow morning it is 50. Tomorrow evening it got confirmed. Means here user interference is nowhere required. User is nowhere required, right? So what happens in automated fashion? Means generating credit card statements for millions of customers. Here user input is nowhere required. But if you are making an online transaction, user input is required. So Hadoop is meant for batch applications. Most of the financial applications are bank applications. Most of the financial applications or bank applications, right? Or batch applications. So Hadoop is meant for storing and processing. For storage, it uses HDFS. For processing, MapReduce or Spark. And here, drawbacks with the current databases. Drawbacks with the current databases. Series. A limited storage in most of these databases. Limited storage in most of the databases. In GBs or in TBs. In most of the databases, no parallel processing. No parallel processing in most of the databases. If volume increases, right, speed decreases. In the databases, if volume increasing, speed decreases. For example, select sum of amount from sales one. Select the total amount from sales one, right? You got 10 records. Select the total amount from sales two. Select the total amount from sales two. You got 1 lakh records. Select the total amount from sales three. You got 1 crore. So which query is going to execute faster among these three? Which query is going to execute faster among these three? Obviously, the first query, right? Total amount from sales one, which has got 10 records. Means here, query to query, as volume increasing, the speed decreasing, right? So among these three queries, this query executes faster because it has got 10 records, it has got 1 lakh, 1 crore. So as volume increasing, speed decreasing. Yes. If complexity increases, speed decreases. Observe here, if complexity increases, speed decreases. Observe this one more query. Select sum of amount from sales one. Select average amount from sales one. Select a standard deviation of amount from sales one. So from this, observe carefully which query executes faster among these three. Total amount, see sales one, right? Think that 1 lakh, the sales one, sales one. So you are applying that on the same table, right? Which query executes faster here? Obviously the first query, right? Because sum of amount, next average amount. Average amount is a two-step process. First sum has to be calculated, next average has to be calculated, right? It's a two-step process. As compared to the first query, second query taking more time. As compared to the second query, third query, standard deviation. Lot of internal processing is required, right? So query to query, right? Query to query as complexity increasing, right? Speed decreases. Understood, right? So complexity increasing, speed decreases. Okay. And databases can handle only structured data. The major drawback of databases, they can handle only structured data. They cannot handle unstructured or semi-structured data. Yes. So the major drawback is databases can handle only structured data. They cannot handle unstructured or semi-structured data. Yes. So just take an example for this. Just observe this right. If you want to take a reviews for a particular movie, NoSQL means not only SQL, not only SQL, right? Structureless, schemaless behavior means record to record different name, different number of fields can be maintained. Record to record different number of fields can be maintained, right? Yes. Okay. For example, if you want to take reviews for a particular movie, if you want to take reviews for a particular movie, think that you got a table. User giving review. User 1, user 2, user 3. In this way, 100 users giving feedback, right? Reviews. User 1 saying 1 if the movie is good. If the movie is good, saying 1. If the movie is bad, saying 0. They are saying in the form of ones and zeros. They're giving the feedback reviews in the form of ones and zeros. Can you write an SQL query to count the number of ones and zeros? Number of goods and not goods here? Observe here, select. Writing an SQL query, review wise, single grouping and single aggregation. Review wise count I want from reviews table, group by review, right? Group by review. So output will be a review wise, right? 1 or 0. Count. 90 people saying the movie good, 10 people saying the movie bad, right? So review wise count from reviews, group by review. So for this, you can write an SQL query, but if the data is like in this way, right? So generally, users want to use that feedback in the form of zeros and ones. They will give in their own text format. Movie is good. Second person saying movie is not good. So in this way, they are saying that they're just giving the review in their own text format. Can you write an SQL query to see the number of goods and not goods? Can you write an SQL query to count the number of goods and not goods? No, right? You cannot you cannot write an SQL query to count the number of goods, even by using this key. Movie is good or movie is not good. So you cannot write an SQL query, right? So even by using keyword count, if you're using this keyword, right? Good. It gives wrong computation. It gives wrong computation because by using this, even not good has got good in it, right? So by using the keyword count also, it gives wrong computation, right? So databases cannot handle this unstructured or semi-structured, right? Yes. But Hadoop can handle all varieties of data, structured, semi-structured, and unstructured. Hadoop doesn't follow client server architecture. It won't follow client server architecture. It follows, it doesn't follow client server request response. It follows master slave architecture. Hadoop follows master slave architecture. Okay. So just what do you mean this master slave architecture? Right. Single master, multiple slaves. Single master and multiple slaves. Single master and multiple slaves. S1, S2, so on, Sn. This we call it like master node. This we call it like slave nodes. This entire thing we call it like a cluster. Hadoop cluster means group of nodes connected in a network. So group of nodes connected in a network. There are two nodes, master node, slave nodes. Master node are in, or we say like name node. In Hadoop terminology, name node. Within this slave nodes, we've got like data nodes. So data is stored within the slaves and data is processed by the slaves. So if you've got a very big file in Hadoop, data is stored in the form of files, f1.txt, 2 TB file, but each system capacity 1 TB, storage capacity 1 TB, 1 TB. This 2 TB file cannot fit into any of the system. So in Hadoop, the data is going to be divided into smaller parts, and this each one going to be distributed across multiple systems. Means two advantages you see here. Data, a bigger data set is going to be stored and processed. Means distributed storage and a parallel processing. The file is distributed across multiple systems and processed by multiple systems parallelly. Parallel processing, distributed storage, two advantages you see, right? So data is stored by the slave systems and processed by these slaves. If they are stored and processed by the slaves, what this master node does, master node, it assigns the task to the slaves. Task assignment. So master node responsibilities, assigning tasks to the slave systems, and the task should be equally assigned to all the slaves. Load balancing. Fault tolerance means if, observe this diagram, fault tolerance. T1 task is given to S1, T2 task to S2, T3 task to S3. These three tasks assigned by these three tasks are executed parallelly by three slave systems. When they're executing parallelly, suddenly a system gets failed. Suddenly, if any system goes down, then the task of that has to be assigned to any other system. That is done by the master, that we call like fault tolerance. When multiple tasks executed by multiple systems, suddenly if any system goes down, then the task of it should be assigned to any other system. That is done, taken care by master. Health monitoring, right? Yes. Before you assigning tasks to any slave, right, should have the health status of each and every slave. Excuse me. Slave node responsibilities. Slave node responsibilities only to storing data and processing data. Slave node responsibilities, storing data and processing data. Advantages of Hadoop, right? So now, advantages of Hadoop. Unlimited data storage. Unlimited data can be stored in Hadoop, right? Because of a feature, horizontally unlimited scalability. What do you mean by horizontally unlimited scalability? Master slave architecture, right? Single master and multiple slaves. Today, if you are running a business with very less number of systems, tomorrow your business has increased, branches have increased, customers have increased, data have increased. So you cannot go with the same number of slaves or systems, right? Horizontally, you will keep on increasing. Horizontally, unlimited number of slaves systems can be added. That is what horizontally unlimited scalability. That is the feature you see, because of which unlimited data storage is possible. Very high speed processing because of parallel processing. Your data is distributed across multiple systems, processed by multiple systems parallelly. Can handle all varieties of data, structured, semi-structured, and unstructured, right? Hadoop is an open source, no licensing required. Hadoop is an open source. Cassandra is a NoSQL database, right? Hadoop, yes, Chetan. Uh, so Hadoop Cassandra, right, is a NoSQL database. What do you mean by structured? Okay. So all varieties of data, structured data means data which is arranged in the form of rows and columns in a structured format, like database tables, Excel files. Semi-structured data means like XML files, JSON files. They are not fully structured, they are not fully unstructured. Unstructured means your chart messages, articles, images, videos, all comes as unstructured. Open source, no licensing required. So most of these Hadoop products are from Apache products. So from Apache mirror site, we can take this and download and you can install it. Commodity hardware, no need of highly configured systems. So Hadoop can run on any hardware, right? It doesn't mean that we need to have very highly configured. No. Yes. So there is a test conducted by Yahoo, right, to test the speed of various databases. Yahoo has taken a table of 100 TB, right? Task is to sorting based on 16 columns. So what is the time taken by different databases? What is the time taken by different databases, right? Oracle has taken nearly 3.5 days. MySQL, it has taken nearly 6 days. Teradata has taken 4.5 hours to process this. Netija has taken 3 hours. Teradata and Netija are through specialized databases used for data warehouse purposes. They have taken hours, and Oracle MySQL has taken days of time. But Hadoop has taken just 3.4 minutes. The latest version of Hadoop has taken just 1.2 minutes. That is what the speed of Hadoop as compared with other things, right? So most of the projects are getting migrating to this Hadoop and Spark environment, especially ETL kinds of projects, right? Getting migrating towards this because of very high speed and huge data storage and high speed, right? Yes. You may get a query, right? Why Hadoop? Why only Hadoop can store huge data? Why only Hadoop can store huge data? Why not? Why databases like Oracle doesn't support unlimited storage? Why databases like Oracle doesn't support unlimited storage? Even for databases like Oracle in real time, right? They can have multiple slaves systems, right? But there is a limit, max limit on the number of slaves. Oracle can go maximum with 256 nodes, slave nodes systems. Beyond that, it cannot support. MySQL 54, MySQL Express 256, DB2 256, SQL Server 256. So all these databases, they can go up to 256 slaves. Beyond that, they cannot support. Teradata, right? It can go maximum with 512. Netija also 512. Vertica, these three are used for data warehouse purpose. But currently Teradata going with 1024 slaves. Netija also with 1024 slaves. Yes. Still, Even though they have got 1024 systems or slaves, still unlimited. Once they get filled, they cannot support data further. But Hadoop, there is no limit on the number of slave systems that Hadoop can have, right? There is no limit on the number of slaves that Hadoop can have. It can go with unlimited number of slaves, horizontally unlimited scalability, horizontally unlimited number of slaves can be added. See, Yahoo, when first time implemented Hadoop, went with 4,000 slaves. Currently, Yahoo using 12,000 system slaves, right, to store its data. Facebook, when first time implemented Hadoop, went with 8,000 slaves. Currently, it's going with 42,000 slaves. So, Hadoop is proven in the market with huge data storage and high speed processing. So, there is no limit on the number of slave systems that Hadoop can have. It can have any number of. So, this Hadoop ecosystem components, what will be discussed as part of this course. So we have got storage components and processing components. Storage like HDFS, Hadoop distributed file system. It is meant for storage. MapReduce, it is meant for processing. It's a parallel execution model meant for parallel processing. Apache Hive is one of the important component of Hadoop, mostly used where we see projects only on Hive. Where it's a data warehouse kind of environment in Hadoop framework. It is using HQL language similar to SQL language, Hive query language similar to our SQL structured query language. Where we see tables here in Hive, tables like internal, external tables, and we can perform querying on that, right? And we have scoop for import or export operation, right? For scoop is for import or export operation. And NoSQL databases. They have got schemaless behavior. Not only SQL, NoSQL means not only SQL, they have got schemaless and random access. Schemaless means for SQL, right? First record to last record, some same number of columns has to be maintained. But in NoSQL, record to record, any number of fields can be maintained. First record with 3 fields, second record with 5 fields, third record with 7 fields, fourth record with 10 fields. Schemaless, we are going to discuss HBase NoSQL database, yarn, yet another resource negotiator. We have got some architectural changes from this Hadoop 2 version onwards. We'll be discussing it in brief, how the processing happens and what are the yarn components. Zookeeper, it controls and coordinates all the Hadoop components, and for connection purposes, for establishing a connection, other things, the Zookeeper is preferred, and controlling and coordinating all the Hadoop components. Flume Kafka also, I'll be giving knowledge on this Flume and Kafka. It's a streaming technology, right? Meant for streaming data. Streaming data means data which keeps on generating, data which keeps on incrementing. Such data, we call it like streaming data, to capturing that data, storing and browsing, right? We use Kafka. Mostly like Kafka is used for the streaming data technologies. And mainly will be more concentration on this PySpark, Spark with Python implementation, PySpark, PySpark core programming, PySpark SQL, PySpark streaming, right? Micro batching we see. And for SQL data frames, where we perform different types. We have got many data frame APIs and also SQL kind of querying, and PySpark core, where we see this RTD computation. That is what this entire thing will be discussing in our course. Yes. So yes. Hadoop is meant for storage and processing. That is mainly used for batch applications, user non-interactive applications. User interactive, we call it like online applications. Hadoop is not for online applications. Drawbacks with current databases, mainly like they can handle only structured data. They cannot handle unstructured or semi-structured. If volume increasing, speed decreases. If complexity increases, speed decreases. Limited storage we see, and no parallel processing. It follows master-slave architecture, single master and multiple slows. And Hadoop cluster group of nodes connected in a network, two types of nodes, master and slave. Master node responsibilities, slave node responsibilities. These are master node responsibilities, slave node responsibility. Advantages, right? Unlimited data storage, very high speed processing, can handle all varieties of data. Open source, no licensing required. Commodity hardware. And if we see the speed of Hadoop as compared with other things, right, where they have taken days of time, specialized databases have taken hours of time, Hadoop has taken just minutes of time. And the storage point of view, it is proven in the market, where there is no limit on the number of slave systems that Hadoop can have. Can go with unlimited number of slaves. Yahoo, when first time implemented Hadoop, went with 4,000 slaves. Currently, Yahoo going with 12,000 slaves. Facebook, when first time implemented Hadoop, went with 8,000 slaves. Currently going with 42. And what are the Hadoop ecosystem components we are going to discuss? Right. So these are the things will be discussed, right? Yes. So, so how exactly the data storage and processing is going to happen in Hadoop, right? So before I want to discuss it, we will have a small break and we'll continue for 1 more hour. So before that, any queries from your side, anyone? Any queries from your side? Right. Weekday batch. As of now, there is no weekday batch. We are going with this weekend. Weekday batch means anyone, if you are wants preferring Python weekday batches are available. You can attend any of the weekday batch for Python if it doesn't have knowledge on Python. But most of this are preferring weekend batches. So most of the students are preferring weekend batches. That's why we are going with more weekend batches on Saturdays and Sundays.
Yeah, hi sir. Manish this side.
Yes.
So, one question, sir, from my side. Actually, I don't know anything about Python. I'm
Hmm.
just a beginner. So currently, I'm working as a ETL developer. Okay, Informatica.
Okay.
So
If you mm.
yeah.
so so yes. So that's what we'll be discussing Hadoop, right? Hadoop,
Hmm.
when we are discussing Hadoop components, right? By the time
Hmm.
parallelly in weekdays, Monday to Friday, you'll be updated with Python. By the time when we start with PySpark, by the time you are 70% of this Python will be completed, right?
Okay.
When you
Okay.
are going parallel. So there are some batches going to start, right? Python batches. So you have got the contact details of the online team. They'll just update you with that. So there is
Yeah.
a message given by the online team. So about the payment process and that contact details of them, you can contact them about this. Morning batches are available, evening batches of Python regular batches. So you can go with that. So
Okay.
about the software, not a worry. I'll be providing the software to your Google Drives, notes to your mail IDs, and a WhatsApp group will be created for technical discussions. And you'll be getting the video of this session every day. Every session video will be available. It will be forwarded to you. Yes, even if you are
Oh,
absent for a particular week.
okay.
Or and
No, sir.
if you are preferring
In
Python also, right? The 2 months, what are the Python course that videos you'll be getting, and this Hadoop and PySpark videos, everything you'll be getting right to your Google Drive.
yeah, one more thing, sir. Actually, yeah. I have discussed with one interviewer.
Hmm.
So he told me that Vertiga is very useful and very fast as compared to Hadoop. And in this session, you are telling like Hadoop is the best.
See,
So,
Vertica is used for, it's a kind of data warehouse kind of. So here, Hadoop and PySpark, we are using currently Hadoop and PySpark both storing unlimited data, right? Unlimited, I'm talking about unlimited huge data storage and storing that, right? I'm talking about that unlimited data storage.
yeah,
So
actually, sir, that Facebook is using Vertica currently, as per my knowledge.
see, 1 second. Means I'm talking, okay, storage point of view and the processing point of view. See, for most of the top 25 e-commerce systems, right? If you see, if we talk about the top 25 e-commerce systems, Facebook, all this,
Mhm.
they are using NoSQL databases currently.
Oh,
NoSQL databases. Yes, because schemaless, structureless, right? Random
mm,
access. So most of this they are using. So as part of the course, I'm providing knowledge on this NoSQL database also. HBase and a part of Cassandra also will be covered as part of this.
okay, sir. Thank you.
Right? So just okay.
Yeah, sir.
So one project will be discussed, right? At that end of this course, project flow will be discussed. Are we having sessions on Sundays also or on that side? Saturdays and Sundays, right? The sessions will be on Saturdays and Sundays. The timing of this batch will be like 4 p.m. every Saturday from 4 to 6, Saturday and Sunday. And sometimes I'll be extending it based depending upon that. So we'll have a break of 10 minutes, right? And again, I'll just keep the meeting in mute and we'll start it, right? How exactly the storage processing happens in this. I'll keep it in mute and the session will start it after 10 minutes.